Hello, everyone, and welcome to another webinar hosted by OVTO, the Open Virtual Testing Organization. My name is Jobin, and I'm a researcher at Chalmers University of Technology in Sweden. If this is your first time joining one of OVTO's events, OVTO is a non-profit organization that works towards advancing open science in the field of open virtual testing, with the broader ambition to contribute to Vision Zero, the global goal of eliminating fatalities and injuries in traffic. OVTO webinars is one of our initiatives to disseminate knowledge related to virtual testing with a particular focus on the tools, workflows, and libraries. In the past year, we have had webinars on fracture prediction, Euro NCAP's virtual testing protocols, and also open source libraries like ArcGen, all of which you can view on OVTO's YouTube channel. If you have been working with virtual testing, whether using Euro NCAP load cases or open source models like the Euro Plus, you may already be familiar with the OpenVT platform, which is hosted by OVTO. Today's webinar is about one of the tools hosted on OpenVT, the Seat Evaluation Tool, or SET in short. It's my pleasure to introduce the speaker for today, Astrid Linder, who needs no introduction to many of us. Astrid Linder is a professor of traffic safety at the Swedish National Road and Transport Research Institute, VTI, an adjunct professor at Chalmers University in Sweden, and an adjunct professor of research at Monash University in Australia. She received her PhD in traffic safety from Chalmers, from where she also has an MSc in engineering physics. Traffic safety, models of the human, and injury prevention are main fields of her research. Professor Linder initiated and led the research resulting in the world's first physical dummy model based on the average female for assessment of vehicle occupant safety. She also has been recognized globally, named one of the BBC's 100 most inspiring and influential women in 2023, and included in Forbes 50 over 50 list for 2025. Before I hand over to Astrid, please note that this webinar is being recorded. We will begin with Astrid's talk now, followed by a Q&A session. You're welcome to submit your questions through the chat. Now, without further ado, Astrid, over to you.
Thank you very much for that very kind introduction. And it's a pleasure to see you. So let's see, here we are. Presentation mode, right?
Now, yes, I can see you.
Very good, thank you. So it's a pleasure to see that so many have signed in, and maybe some are still joining to this webinar. I will, in this presentation, with the focus on the sets, the physical models that can be used for in the virtual toolchain, take some time to give you some of the background for the work that has been done. And for some of you, it will be very familiar, and for some of you, maybe a reminder of some of the details of why this is important. Jobin described my background. I could also highlight that as part of my PhD, I was one of the two PhD students developing the let's see, I get a better cursor here, just bear with me. Here we are. Yeah, I hope you see my cursor. Do you see my cursor?
Yes, I can see.
Very good. Yes. Thank you, Jobin. Yeah, so as a PhD student, I was one of the two students in the project where we developed the BioRid, the average male model for low severity impact testing. And then I will tell you about the journey since then. Just a reminder of the broader picture here. we have nearly 2 million fatalities per year in the world, and serious injuries in the range of 20 to 50 million yearly. So this is an epidemic that is global and very serious. It's actually the main cause of death for young people, 12 to 30, something in that range, where this is the most common way of losing their lives. So it's important for us all. In the assessment of protection, when we narrow down a little bit here to looking at the vehicle, then we for the different crash configurations use the average male as the representative of the whole population. You know that we have a small occupant in frontal and a large occupant in representing the frontal crash, but in rear impacts and in side impact, we solely rely on the average male. We also know very well, and I will remind you of some of the details here, that men and women in different impacts types and for different injuries sustain different level of protection. And the largest difference here is when it comes to soft tissue injuries, whiplash injuries, which is the most common disabling injury, and where the risk for females are in the order of double of those of males. So narrowing down now on whiplash injuries, and not only initial symptoms, but permanent medical impairment, 10% or more, which means that you, with these injuries, have something, it affects your life every day, right? For the rest of your life. And when we look at where these occur, these are figures from Sweden, we have two main categories. It's car occupants and it's cyclists. Of course, with two very different type of, the categories have different injuries, but this is where we find the injuries with permanent medical impairment at 10% and higher. Zooming in now on car occupants, as you can see in this graph, percentage here, cervical spine, neck, totally dominates. Another piece of very important, very important data, or the fundament for guiding us to where to focus our attention and our efforts is, of course, in-depth or different type of very detailed injury data. And this, I will remind you about this data that comes from Folksam. It was published 2020, and it looks at the development of the safety of cars since the 1980s. A reminder of the amount of data in this study. It's more than 100,000 two-car crashes. It's nearly 150,000 diagnoses and over 50,000 occupants. So this is the scale of the material here. The material is, or the data is divided into 10 years increment of the vehicles. So you can see here 80s, 90s, 2000, first 10 years, and then 2010 to 19. And I just want to highlight some of the details, or overall some of the data here that we can see. Yes, we have an improvement. Now it's divided into males and females. We have an improvement by these year models for both males and females. However, the difference in risk remains for when it comes to males and females. And here you see you have serious and fatal injuries, fatalities, where there are fortunately fewer cases now, so larger error bars. I want to highlight in particular permanent medical impairment. Here's all permanent medical impairment, where the difference in risk between females and males remains. So there are room for improvement in terms of identifying what works the best and how to promote the best performing vehicles. Here, again, just confirming what you saw before, that what dominates when it comes to permanent medical impairment here is 1%, is for both males and for females is the cervical spine. So this remains an important area, even if we don't talk about it so much at the moment in this community. But yeah, it goes in waves, and this is at least a reminder of why it still is very important. So more background data, talking about neck injuries. We know that re-impact dominate, but we also know that a big part, in the order of 40%, is in frontal impact. And that is something that I know that several of maybe you that are attending today have started to focus on, which is of course also very important, where the countermeasures are different than in the rear impact. In rear impact, we think of and talk about and addresses it by looking at the seat, but in front and the seat back performances in particular, and the seat cushion and so on. In frontal, there are other possibilities of preventing us from getting these injuries. And the hypotheses for these injuries are in the early phase of the motion, where the head translates relative to the torso, which can of course occur in both what we call retraction, which is shown here, but also in protraction in the other way. If the torso is kept in close to the seat, and you have a frontal input, and then your head goes like this. So, and just a reminder also of the injury statistics back from the 60s and onwards, showing here males and females. It's both in risk of injury and differences in odds, where the females are less well protected and have shown to be less well protected for a long time. So, in re-impact, focusing in on that, what can be done? First of all, if you look at the overall picture and look at how seat performs, this is again from Folksam, where we have two different categories or three different categories of seats: standard seats, seats with reactive head restraint of some kind, and a category of the Volvo whip seats and the Toyota wheel seat. So if you look at the overall picture, then you would you rightly draw the conclusion that safety are improved by in both these categories compared to a standard seat. But as several of you have seen before and are well aware of, when we divide this data into males and females, the picture is very different. And here you have the standard seed, here you have the reactive seeds with reactive head restraint, and here we have the will and the whips. And you can see here, which I think is very encouraging and that we should focus on, is that in two different ways, two different car manufacturers here have shown really promising results for both males and females in two very different ways. Those that have been working on the reactive head restraint has been very successful in providing improved safety for the males, but not for the females. So these are the things that I think we should highlight better than we do today in our assessment of new cars. Okay, now focusing on the sets. The set is the seat evaluation tool. It's a physical tool. So where did all this start? It started with the biorid. Before that, we didn't have any tools or crash test dummies for low severity impacts. So I told you about this guy before. Then we moved on in the, 12, 13 years ago, this was released where we did an average female equivalent of the biorid, the average male, virtually. So it's done with the same design, the same, everything the same, apart from that the Evarid, as her name is have the proportion of an average female instead of the biorid, an average male. Moving then fast forward to the virtual project, where we not only developed the crash test dummies, but in particular, and with the highest focus, were on the Viva Plus models, which is human body models of an average male and an average female. And so, most of you in this seminar is probably very well aware of this. And then for the low severity re-impact case, we then did also the physical model, the seat evaluation tools. For those that are familiar with the biorid design, you see here that it's based on the biorid design, but also improved in many ways. So now to some recent tests that have been done with the sets. Here you have the sets seated in Saab 9.3 seats. We selected two different types of seat from the Volkswagen data. These are the Saab 9.3 and the Audi A4. And we selected them because they have very different protection performances for females and males. Saab with much higher a risk of injury for females and zero for males. The Audi seat shows the opposite, where there's a higher risk for males than for females. And what I want to show you in this part of the presentation of these tests is how we have developed the software OS DIMA by Hjort, where we can, from the sensors of the vehicle, of the dummy, can extract motion, so that you don't have to do film analysis to do that. So first, I just want to show the test as such. Here you can see to your left, you see the average male, and to the right, you see the average female seated in the top seats. And what becomes very clear is that now it says that it's something wrong with the how this comes forward. I hope that you saw that there are quite some differences in dynamic performances of these seats, depending on both the size of the occupant, of course, and its geometric geometry of it, and then what it contains in properties in terms of joint stiffnesses and so on. I can just show you, I hope this goes through. This is in the Audi seat, which deforms much more than the sub seat. And for the male, it's something that I have seen before. When sometimes you can see in a seat where the seat moves away from the head or from the torso in the same, or moves backwards in the same way, in the same rate of velocity as the dummy, and then the dummy isn't supported by the seat because it always moves away, and then the dummy does the same. So just an example of two different ways, or two different seats. And there are some publications in preparation for this, but now I will want to share with you what we did with this the software. And it's called OSDIMA by UT, and will shortly be available on the OpenVT. It was presented at the ESV conference last week, and here you see the sensor data and the video data, and with a very good agreement for throughout the whole duration of the part where we have a focus on. Right here is 300 millisecond. It's not identical, which it shouldn't be, because then you would be suspicious, but it's very, very similar. And the same goes for T1 displacement. Here you can, and it's both from the Audi seat and from the sub seat. Yeah, in both columns. So this shows a possibility to, in particular, then of course, monitor motion where you can, which you cannot track with field markers and that you are interested in, as for example along the spine, where you can, we put sensors on T8, 8 thoracic vertebra, and that one we cannot monitor by field markers, but with this technique we can look at the motion on that level as well. Just to shortly also what you find in the paper about head relative to T1 displacement, and both in horizontal plane and angular motion, because we want to capture the differences in dynamics that you saw in the videos. And when we look at the horizontal displacement, head relative to T1, and this is also addressing a question that I sometimes get. Oh, but can we scale the result of the male and then get the result of the female, or do they show different things? Here, when it looks, when we have the horizontal displacement, the values for the peak values for the male is larger for both the Audi and the sub seat. And looking at the angular displacement, the males are the dotted line, and the females is the green line. Here you see the opposite of the previous slide. The peak value for the female is larger, just as an example. Then I also want to show you what we have done with using the sets in a test setup and looking at the deformation of the seat cushion. So they have the male and the female have different geometry of the hip area, and of course, and also different weight. So how does that manifest itself in the initial position or in the deformation of the seat cushion before you start a simulation or a test? And just a reminder of the contours of the hip area and the males and the females in general. But in the hip area here, you can see females having a wider hip area compared to the male. And when we put these two models in the seat, where we have pins going through the seat and measure how much they are pressed down by the models, we see this is the male and this is the female. So you can clearly see how they sink into the seat cushion differently, which is expected, but still, this is one way of quantifying that. And here are the measurements in millimeters, as you saw on the graph before. We have also done component tests for tuning of the recent development of the FE set, the 50F, and also soon it will be available, both this one and the equivalent average male model. This is a fantastic collaboration that we have done together with Toyota, and it will we have a manuscript for COVID this year. So if we are able to get all the details needed into the manuscript, then you will hear about this more in Munich. Just some pictures of what we have done in terms of the component test. We have done drop tests on, here you see, this is a thing dropping down on the test cube here, and here you see close to where it's impacting to get the properties of the stiffnesses. This has also been simulated. Of course, we are talking about virtual testing here, and now we come into the component testing. So in the same way, we have looking at the how the spine react to different loading conditions, and have also done this in this is for the cervical spine, and this is for the thoracic and lumbar spine with different weights applied to different parts of the spine to get these numbers, and of course doing this in simulations as well. So with that, in short, a bit fast forward, but still I wanted to give you an overview. As I said, the FE sets, the average female and the male will be available soon at the OpenVT, and you can hear more about both the testing with the sets in a short paper, short communication at IRCOBI, work that we have done together with TS Tech, and also hopefully you can hear about the development of the FE sets. So with that, thank you for your attention.
Yep. Thank you, Astrid. Yep. That's a nice presentation, great overview, and nice that you took us from historical perspective there, right from the beginning, and nice to see the motivation for the development for the set. A reminder to everyone, we take the Q&A on chat. So you're welcome to put in your questions in the chat.
Should I stop the, let's see here. Can I stop the sharing somewhere? Do you want me, or do you want me the presentations to still be there in case you want to go back in something?
I think, yeah, it's good to have it still on
Okay, I
presentation
keep
mode
it like this then.
in case we need to go back for
Yep.
questions. So,
Okay. But then, yeah, I should say now it's open for question, and I made it short for us to give some give at least some time, hopefully sufficient time for questions and dialogue.
yeah, I think we have the option to like use the microphone if someone wants to ask questions also. I've not tried that in webinar mode, but why not give it a try also? I think it was nice that you brought up the permanent medical impairment for the about the cervical spine. And a lot of the cases in crash databases, injuries are marked by AIS, and then it's mostly the acute injuries that are marked. And there's this long-term perspective, we miss it out completely, which could be a reason that this is often neglected, cervical spine injuries and
No, but
soft tissue
you need,
injuries. Yeah.
yeah, it's good. It's a good good to highlight this, Jobin, because you need another source of data. It's the hospital don't follow up. It's not their work. The AIS code is meant to give you a severity in terms of how high is the risk of death, right? And it is not within the range of or reach, or it's not at the hospitals where you follow up. If you get some kind some serious effect in your life, and it's so you need different sources of data here, and that's why insurance data is so important to have access to also.
Yes, I think so. And that's where we get the long-term perspective then. Yeah, that's great. I can see the questions are coming in. I think the first one, yeah, is about the data set itself. Karan asks, what was the data set used for the male-female difference in the crash statistics?
What data?
What was the source for the data? What was the data set used?
For the difference, to identify the differences. So there are different data sources from the 1960s and onwards. So when it comes to whiplash, when it comes to, and we have also seen this for if the question is about overall injuries, then of course it's a different references. I probably should point to the most recent most recent largest study by Craig et al. It's a report from NHTSA that came early this year. Some of you might be aware of, there was an article a couple of years ago, and that contained some errors that now has been corrected, and so that is a massive part work done to highlight or identify if there were differences, because that's the main question in that report. Are there differences and in injury statistics, and if so, what type of injuries and so on. So 150 models have been created in the Craig et al. Study, and out of those there were 30 something that were significant higher risk for females than males. There were none of these 150 models that showed higher significant differences for males than females. When it came to results that were not significant but still indications, there were a majority of the studies showed an indication of higher risk for females, but also a number of cases or models that were were generated showed higher risk for males than females. So it will vary, as you saw also when it comes to the Saab and the Audi seat. You can find both differences in both ways. And so this is very important that we learn more from what has happened, but also keep that in mind when we do the assessment of safety of new cars, I would say.
Yeah. Maybe yeah. Karim says thanks, but I could also add the Swedish data that you were showing, Astrid from Folksam. They've used information from Strada also, and that's a Swedish database.
Yeah, it's a database where we are able to connect, we collect and connect data from both police reported data and hospital data. And then we get a fuller picture. And then we, in addition, we have the insurance companies and with their knowledge of where we find the impairment. For example, when it comes to bicycles, it's something else than the focus of this presentation, but still important. And most of those bicycle crashes are single crashes. We have the same when it comes to vehicles. We have a lot of single crashes, but they show up in police report. Single bicycle crashes don't show up there. So if you rely on police reported data only, you will get a part of the detailed data on some parts, but you will miss other parts.
Yeah. And permanent medical impairment, that's a decision made by medical doctors. If I remember right, it's at 3 years after the injury has happened, and when they don't see any more improvement in the health, they label the impairment as permanent. And I think that is maybe very specific to Sweden. I don't think there are other sources of data similar to that, or there may be. I'm not aware of that. Okay, we have some more questions here. Martin, we have a question for Martin. Thanks for a nice presentation. I wonder if the set would work also for low-speed frontal crashes to evaluate whiplash.
Yes, very timely to ask that question, as we know that we haven't paid attention to that low severity crash type, and we have a high number of injuries also there. So the sets are prepared to being able to be used in frontal impact, but our focus in the development in the virtual project was rear impact. But it's prepared in the way that if you compare the sets to the BioRid, it's based on the concept of the BioRid. However, it's made more robust in terms of how the spine is designed, but it also have rotational elements along the spine, so that because in frontal, in a rear impact, you get a long way with pure sagittal plane motion, which we can generate with the BioRid, right? But in the frontal, we at least in Europe, we aim at protect and assess the protection of a belted occupant. And a belted occupant would typically have a 3-point belt. And then you will get rotation of the torso in a frontal impact in a very different way than you get in the rear impact, where you have the whole seat back supporting your torso. So there is this capacity of the sets, and it is a work to be done if you yeah, that could be done if the initiative is taken to refine that part of the capacity of the sets, but it's prepared for it.
Yeah. Thanks, Astrid. I wonder if Martin had a follow-up, or if you had, you could and try to unmute yourself.
Yeah, we can have a dialogue. That's fine.
Is it working now? Do you hear me?
Again, no, I can hear you, Martin.
I can hear you.
I'm very happy for the answer, Astrid. We started to discuss frontal whiplash a long time ago. Actually starting something out there, so it will be very interesting sooner or later to actually evaluate also the set in the work we start up. But maybe it's enough for today, and we can take follow up.
Yeah, please do. But it's very good that you asked the question, and that I'm aware of that there is an interest for that. It will be, the sets will later this year be used in a lower severity frontal impact situation, where we look at in particular the interaction with the seat back, but that's very low severities where we do or it's a Austrian project where there's a focus on looking at how the seatbelt interaction in particular. So in a simplified sled where we do it's volunteer tests are done, and then we'll also use the sets. But that is like a 1G, something like that. But of course, they should work in the same range as they do in rear impact. That's how the design is done in terms of robustness and so on. So that should be up to 25 kilometers per hour, thereabout.
And that is typically what we are looking at, 15 to 25 kilometers per hour. When we looked into the GIDAS data that we present on Narcobi last year, we have 40% of the whiplash AS ones in this 16 to 25 kilometers per hour speed range. So I think that would be super interesting to look into. But I think I will send you an email and try to have continue this discussion. But before I have one more question that we actually discussed this morning, and because I'm not an expert in the dummies for rear impact. So when you compare the BioRid or the BioRid 2 to the set, and in the design to interact with the shoulder belt, you say that the set is more robust compared to the BioRid?
I was. Thank you for the question. I was talking about how the spine is designed. Maybe it was fast forward, but you could see when I showed the spine. It's aluminum blocks and more robust design than the. So we have incorporated a lot of the experiences, you could say, from the BioRid. It's me and Mats Svensson at Chalmers, so he was also part of the initial BioRid project. So that is one part, the spine. But in addition, we have a movable shoulder, which the BioRid doesn't. And that is, of course, again, you could have an effect of this a bit when you go into the seat, but in particular when you do like this, in a frontal impact. So this design is influenced by the work of Fredrik Turnvall, I think, Turnvall, which is now part of the Thor. So in that respect, it's different from the BioRid.
I think you had a figure, Astrid, with the spine. Maybe that it helps to see it on one of your previous slides.
Yeah, I hope I can go back.
So,
Yeah.
okay.
Yeah, but here you see, this is the spine, and you have here is the torsion element that you don't have in the biorid. In biorid, only sagittal motion. Here you have the vertebrae where you can have rotation. Was that your question, Martin?
I think that was one part of it, but I was thinking about the shoulder is interacting a lot with the shoulder belt, and I don't know, in the rear end you typically don't have that interaction, so maybe the biorid doesn't have a good shoulder for a frontal
No,
impact, or is it?
it wasn't our focus when we developed the biorid, so
Exactly.
it would be very surprising if it had.
So if you were to pick one dummy for sled testing to evaluate frontal whiplash, you will pick the set in front of the biorid. Is that correct understood?
Yeah, I would probably. I use the sets both in rear impact and in frontal, but if you want to stay with the biorid, then you choose only. You can complement him with the average female sets in rear impact, but in frontal, absolutely. This is designed with that impact direction in mind. And that's not the case for the biorid.
Thank you. I think that was the answer I was looking for. So it's very good. Then we know we should use a set, not the biorid. But we can come to that later, how to, because I guess there is a limited number of set dummies to be used. Or
At the moment, we only have one of each.
yes, exactly.
And but they are in Linköping, so they're not so far away from you.
Very good. So as I said, I will come back with more discussion later. Thank you very much for presentation. And
yeah, thank you for the question.
Great. Thanks, Martin. We have one more question there about validation of sets from Porta. And the question was like, so my question is a set validated with any of PMHs or PMHs cadaver tests from other sources?
Yeah, it's validated to, in low severity crashes, we have a source of data that you don't have in higher severity crashes, which is volunteer tests. So it's validated towards a set of male volunteers and female volunteers. The male volunteers were the ones that those tests we did for the development of the biorid, so those were published back then. Now we are talking 90s, right? And an additional set of data, I initiated a study doing the same type of test with the equivalent, with also a set of, or also females, right? So you have male volunteers and females volunteers, and then you create the corridors in the same way. So both these sets of volunteer data has been published before, but also the validation. Of course, then the sets have been run in the same seed as was used in the volunteer test, and all that is found in the appendix in the VTI report 1147A, Karamur et al. I think I have, there you have the reference.
Yeah.
So in terms of cadaver data, which of course you need if or PMHS when you go at higher speed, then the only set of data that I'm aware of is the data that we use for the development of also validation of the biorid, where you have pendulum test on specimens seated on a bench. That study by Viano et al. Only contained male. So I'm not aware of any data that could be used for the validation, but if anybody around the virtual table is, please let me know. or if it's not available, then would be a very important study to conduct.
Yep. Yep. There's no follow-up. I guess I can see it. Dr. says, thanks for the answer. That'd be nice. Thanks, Astrid. I don't see any more questions in the Q&A unless someone has any follow-up to the answers or the discussions that we have had now, which I don't see coming in. But really interesting discussion, and I think very timely, both for rear and front impacts. With that, I hope we continue the discussion in other forums. It could be coming up there. Astrid, you mentioned a couple of presentations about SET there, and I'm aware of multiple projects going on, using SETs, looking at similar topics. I look forward to seeing more of this from the community. So let me thank you, Astrid, on behalf of everyone here. Thank you very much for the really nice presentation and the discussion today.
No, my pleasure. And thank you for all the participants and the very good and well thought of questions.
Yes, I agree. Thank you, everyone. Thanks for today. See you later.
Okay, see you then.
Yeah, bye-bye.